Hello, everybody. Hey, we're going to have a short little video on help with motion worksheet number 10, which is 6.2. So if you guys look here, you guys will see the answers to the worksheets. We'll see the answers to the worksheets. And then I'm going to do a couple problems to kind of help you figure out what is going on. Okay, so you guys, we're going to start with problem number 4. All right, so I'm going to close this up, and we're going to start with number 4. And number 4 says a rocket is launched straight up from the ground, and it goes upwards for 3.25 seconds. All right, so I'm going to, like you probably should do, okay, is list those variables, and then you can fill them in. So we do know what the final velocity is because it goes to the highest point, okay? And at the highest point, the velocity is going to be 0 because gravity has momentarily stopped it, right? So this is going to be 0. And this initial velocity, we do not know what it is. Okay, acceleration, we do know what that is, and that is g. It's gravity, which you know is 10 meters per second squared. And that's going to be negative. Okay, and we know the time is 3.25 seconds. And we don't know the distance, which is what we are looking for. Okay, now we sometimes in these things we're going to have to do an equation in order to solve for an equation. For example, even though we're looking at distance, right? There's a distance in number 1, okay, but we don't know what the average velocity is, and we don't know what the final velocity is, so we can't use that. And here is distance in problem number 3. But we don't know what the initial velocity is, so we can't do that one directly. So what we're going to do is we're going to use this one right here. We're going to solve for the initial velocity, and then we could either go up to here or we could go down to here to solve that. All right. So we're going to go to equation number 2. V final is equal to V initial plus AT. Final velocity is 0, and our initial velocity we do not know. That's what we're looking for. Minus 10, okay, from right there. And our time is 3.25, okay. Minus 10 times 3.25 is negative 32.5. So 0 is equal to VI minus 32.5. Now we want to get this all by itself, so we're going to have to add 32.5 to both sides. And we're going to get 32.5 meters per second is equal to our initial velocity. All right, so even though we've done that, okay, we have not answered the question. We have not answered the questions. So now we can actually go into, let's say, equation number 3. Now we could go up, figure out what the average velocity is, okay, which would be about 16.125, okay, 16.125, now we have 3.25, and we could calculate the distance there. But I'm going to use this equation right here, okay, distance is equal to 32.5, okay, times, I'll go ahead and put it out into the formula first. VIT plus 1/2 AT squared. So this is 32.5 times 3.25 plus 1/2 of negative 10 times 3.25 squared. Okay? And if we plug that into our calculator, 32.5 times 3.25 is 105.625 minus 0.5 times 10 times 3.25 squared, and we're getting 52.8, okay? So our distance is equal to 52.8 meters, okay? And that is the answer. That is the answer we're looking for. All right, so I'm gonna go ahead and look at problem number 6. Problem number 6. So I am going to erase this, and again, we have all our variables. All right, so problem number 6. A rock drops off of a wall and it takes 4 seconds to hit the ground. We've got 4.0 seconds. Okay, if we drop a rock, what is its initial velocity? And the answer is 0 meters per second, okay? If we drop a rock, what makes it go to the ground? Gravity. So we are going to say negative 10 meters per second squared. Now remember, that negative means down, okay? All right, and we also have, we're looking for distance and final velocity. Okay, so we're looking for this and we're looking for that. All right, so if we look at equation number 2, we don't know V final, but we do know V initial, we know the acceleration, and we know time. Okay, so we can use that equation. So V final is equal to V initial plus AT. So this is going to be 0 plus negative 10, okay, times 4. Okay, so that V final is going to equal to negative 40 meters per second. Now, what does that mean? That negative means downward. And this is kind of where we kind of go with the difference between speed and velocity. It's going 40 meters per second, okay? Well, in which direction? Now, it is going down. That may be obvious. So if we go back, you guys, if we go back to this one, I said it was positive 40 meters per second. And that's really just saying what its speed is, because I'm not quite talking about the direction, but the direction would be down, which if you read the question would make sense. Okay? All right. So now the next thing we're looking for is this distance. If we look at equation number 3, okay, we can get distance or displacement that is equal to VIT plus 1/2 AT squared, okay? So again, this is going to be equal to 0, so that's going to go away, plus 1/2 times negative 10 times 4 squared, and we put that in there, okay, and that is going to give us a value of 80 meters. Our displacement is 80 meters, and that is down. And just like before, so technically speaking, it's 80, but the distance it went was 80. Now, if you put negative 80 or negative 40, that is actually probably a better answer, but there you have it. Okay, so this is the end of this little help video for worksheet 6.2. Thanks, and see you next time.